Welcome to the Wire Reinforcement Institute's Tech Check titled Welded Wire Reinforcement Nomenclature and Procurement. Tech checks are intended to provide specifiers, contractors, and other construction stakeholders with information needed for successful welded wire reinforcement implementation. In this tech check, we're going to divide our conversation into two parts. First, we're going to talk about welded wire reinforcement sheet nomenclature. We'll discuss the style components that comprise that nomenclature, and then we'll give an example of a variable welded wire reinforcement mat. From there, we'll move into procurement, and we'll talk about stock material and custom material. Note that in this presentation, welded wire reinforcement in heavy roll form, like that which is used in structural precast concrete pipe, is not covered. So let's talk about style components. Welded wire nomenclature is presented in terms of a particular mat style. Really, that's just a written description. So for this presentation, we'll break that into lettered components or lettered attributes on the left side, and these will correspond to the illustration on the right side of the slide. The first component of a welded wire reinforcement mat style is attribute A, and this corresponds to the line wire uniform spacing. A line wire is nothing more than the long wire on the fabricated mat of welded wires. So here we have 7 equal spaces of 11 inches, so that attribute A is 11. The companion to that is the spacing of the cross wires that run in the transverse direction. So attribute B, here we see we have 10 equal spaces of 23 inches on center, so we have an 11 by 23 pattern. So A is line wire, B is cross wire. These are uniform spacings. From here we move into the actual wire sizes themselves. So attribute C, we're back talking about the line wires or the long wires on the mat, and we see that these long wires are denoted as D26.4. The D simply indicates that it's a deformed surface, similar to a piece of rebar, and the 26.4 is a designation that refers to 1/100th of an inch of cross-sectional steel area. So this particular wire is 0.264 square inches. So we see again attribute C designates the line wire size. Attribute D then, which will be the companion to the previously described attribute B, is the cross wire size. And so we see we have a D11.5 here in the cross wire or transverse direction. So the D attribute here is D11.5. Now, having established the spacing and sizes of the wires, we move into the overall size of the sheet. So attribute E is the dimension between the outermost line wires. Here that's 6'5" or 77 inches. So that is measured from center line to center line of the outermost line wires. Attribute E sub 1 and E sub 2 is simply the overhang of the cross wires beyond the previously mentioned outermost line wires. So here we see in the diagram we have a 1-inch overhang on each side. That would then correspond to a +1 and a +1 for the attributes E sub 1 and E sub 2. So again, these are cross wire overhangs that are beyond or to the outside of the outermost line wires. Now we move on to attribute F. This is the overall length of the welded wire reinforcement mat. So that's from end to end of the long wires or line wires. So in this case, we have a 20-foot length, so attribute F would be 20 feet. And last but not least, we've got to be able to describe the line wire overhangs. Line wire overhangs are designated in this illustration as 5 inches and 5 inches. So you can see that the attribute F sub 1 and F sub 2 are noted as 5 and 5. A key point here is that for the line wire direction, those overhangs are actually inclusive of the overall length. So in the end, the style for the illustrated mat is as follows. We have 11 by 23. Again, those are spacings. We have D26.4 over D11.5. Those are the wire sizes. We have a 77-inch width from outermost line wire to line wire, and a +1 overhang beyond those line wires to the outside. Then we have a 20-foot overall length with a 5 and 5 overhang inclusive. So mat configuration variability, modern equipment is able to produce welded wire reinforcement mats just based on the modern aspect of the welding machines themselves. On a given mat, you can have variable line wire sizes, spaces, and lengths. The same goes for the cross wires. You can have variable overhangs, and you can actually mix deformed and plain wires on the same mat. Now, there are practical design applications for this. You could have staggered patterns of reinforcement as required by the design. You could have targeted steel areas that are increased in localized areas within the mat coverage. And then you could also have certain spacings that are set up so that they avoid embedded features that are going to be placed in the concrete local to where the mat is going to be positioned. So if we give an example of a variable mat, in this case, we'll do a mat that has variable spacings. We see on the front end of the style in red and in blue, we have V1 and V2. So V1 is a variable spacing of line wires, and V2 is a variable spacing of cross wires. And you can see the arrows off to the right in the illustration. We're moving from left to right for the line wires, and we're moving from front to back, or as drawn, top to bottom for the crosswire spacing. Notice that the balance of the style is as what we discussed before. We're talking about wire sizes of 26.4 and 11.5. We've established an overall width of 77 with the +1 overhangs to the outside, and an overall length of 20 feet with a 5-inch and 5-inch inclusive overhang. Where the difference is, comparing this style to the previous, is that the wire positioning within the body of the mat has changed. So if we look at line wires, which is V sub 1 or V1, we have a 1-inch overhang, and we have a 7-inch space, a 12-inch space, three 13-inch spaces, another 12-inch space, a 7-inch space, and then we conclude it with a 1-inch overhang. Similarly, we have a variable pattern in the crosswire direction. So this shows that with a style, you can still describe a welded wire reinforcement mat with this written description. It would not necessarily have to be accompanied by an illustration, but when you get into a high level of variability, say the wire sizes themselves, you have different size line wires or different overhangs, and you start increasing the variability on a given mat beyond just the spacings in each direction, you'll see that the importance of accompanying that written style with an actual illustration is critical. Here are just a few examples of some variability that you can see on the mats. If you look at the photograph in the upper right corner, you can see wire sizes of various spacings and sizes in both directions. While you could certainly attempt to generate a written style for that mat, ideally that's going to be accompanied by an illustration. That's going to be the best way to communicate what comprises that structural mat. Let's move into procurement. Generally speaking, there are two categories of welded wire reinforcement available in North America. First, there are stock styles, and then what we would refer to as project-specific styles. Stock material is typically light gauge, normally for non-structural usage, nominal usage. It's often referred to as building mesh or standard mesh. It is considered a commonly available item, and it's typically characterized by wire spacings of 4 inches to 6 inches with wire sizes that are W4.0 and smaller. This often includes W2.9, W2.1, and W1.4. Note that there are deformed versions of some of these smaller wire sizes as well. Normally, this material is produced in flat mats or rolls. Availability-wise, you could get it manufactured direct, but you will also see the material available from construction materials distributors, as well as some big box construction retail hardware type stores. Rarely, if ever, are you going to see this material accompanied by a technical drawing because it is a repetitive spacing in both directions and a repetitive wire size in both directions. So the sheet style itself is quite straightforward. Here is just this just shows a few snippets from different welded wire reinforcement producers that show the stock sizes, and you can see the 6x6 and the 4x4 patterns, and the fairly small wire sizes there that are available that generally describe uh, the, the stock material. Now, from one producer to the next, the offerings will vary slightly, just based on what their customer demands are. But you can kind of see some commonality here in spacings and wire sizes. If we move on to project-specific welded wire reinforcement material, this is typically for structural applications. Sometimes you'll see it referred to as engineered welded wire reinforcement or engineered mesh, as just a term intended to differentiate it from stock material. You can have heavier wires with this project-specific structural welded wire reinforcement up to about a number 5 rebar size. That would be a D31. It's highly customizable, as we touched on earlier, with variable sizes, spaces, and lengths in both directions. This is typically furnished in flat mat or bent mat, so you can run a flat mat on the welding machine, and then it goes straight into fabrication where it would be put on a bender, and you could have a bent mat shipped to the project site. Availability wise, typically you're going to get this material from welded wire reinforcement manufacturers or their affiliates directly. Typically, you will not get this material through, say, a general construction material distributor. This would be better targeted to have the relationship with the manufacturer and or their affiliate directly. Furthermore, because of the structural nature of this material and the potential variability of the arrangement of wires and such on a particular mat, you will see this material accompanied by manufacturers' illustrations or shop drawings, basically, to ensure the full clarity of the welded wire reinforcement style and the project arrangement. This is a value-added service. Typically, it's built in to the cost of the product. And lastly, from a corrosion protection standpoint, the material can be epoxy coated or hot dip galvanized. Here are a few photographs showing some examples of some custom material. Obviously, these are arrangements of wires that, if you were just to go by the written description or by the style, it may not be enough to tell the full story. So when you get into structural material like this, you are almost certainly going to see it accompanied by a shop drawing for approval purposes. And again, this note just reinforces that. You're going to see detailed shop drawings accompanying this material, and all of the WRI member producers have technical staff that actually generate these shop drawing submittals, no different than what you see for rebar submittals. Here are a few illustrations of, these are actually snippets from actual shop drawing submittals. You can see these are building footprints over on the left side, showing the arrangement of the different mats that comprise the elevated slabs. And then over on the upper right, you see the actual illustrations of the actual mat designations that are called out on plans. So again, when you get into structural material, the main takeaway is that it's going to be a highly illustrative shop drawing submittal for review by the designer of record as well as the contractor. Then in the lower right, these are actually tilt wall panel elevations. You can see that this particular detail uses a color-coded method to show how the layout of the mats is arranged in two different wall panel elevations. So again, the takeaway as it relates to procurement, suggestions we would have would be for stock material, simply provide direction on the quantity and the welded wire reinforcement style, as there is very rarely any manufacturer technical involvement needed in the procurement process. In contrast, for project-specific or engineered welded wire reinforcement material, The customer really should provide to the manufacturer the contract drawings and specifications that identify the usage of the welded wire reinforcement. This will in turn allow the technical staff to carry out an accurate welded wire reinforcement takeoff and detailing effort that is specific to the project in question. So really treat the process for the structural applications using welded wire reinforcement, treat the process the same as it's done with rebar. For more information, please visit the Wire Reinforcement Institute's website. Thanks for attending.